Hello, this is the final video project for the Intro to Nanosystems Engineering class. Our project is on graphene batteries. It's made by Janae Dotson, Nicholas Jones, and Jonathan Tyrone. So, let's talk about graphene batteries. What are they? How can they provide us advantages? And what are the obstacles in utilizing those advantages in an industrial setting? So to start, we're going to look at what graphene is. Graphene is a carbon-based material which is the thinnest and strongest material on Earth. It is made up of single layers of graphite, one of the most common forms of carbon, and diamonds. Graphene is a very thin material. It is atomically thin. In fact, so thin that to cover an entire football field with graphene, it would only weigh about 3 grams. So how did we discover graphene, and where and when? So in 2004 at the University of Manchester, Professor Andrei Geim and Kostya Novoselov were able to figure out how to obtain graphene from graphite. And they did it very simply. What they did was they've placed tape on graphite over and over, continuously splitting the flakes until reaching a single atom thickness. And as you're probably saying, this took a long time, which it did. So, now that we have an atomically thin, very strong, and very light material, what can we use it for? Well, first, let's talk about its ability to be a supercapacitor. So what is a supercapacitor? So let's start first with what a capacitor is. It is an electrical component that is able to charge and discharge very quickly, but it doesn't store much energy. So as a battery, a capacitor would not be very beneficial. A battery, on the other hand, can store a lot of energy, but it charges and discharges slowly. Where graphene steps in is graphene's unique properties allow it to blur the line between a capacitor and a battery by providing a very quick charge and discharge ability and also being able to store power. This allows it to be a supercapacitor with all the properties of a capacitor and a battery in one. So let's talk about graphene as compared with current batteries. So lithium ion. Lithium ion is outclassed by graphene in its ability to charge and discharge. Graphene exceedingly surpasses it. Also, graphene is highly conductive, which allows it to produce a much higher current than lithium ion batteries. Also, graphene, because it is thin and able to conduct heat very well, it allows it to dissipate heat that is generated from battery operation, which allows it to be much safer than lithium and allows it to extend the life of the battery. And due to its two-dimensional nature, seeing as it's atomically thin, graphene allows a much higher storage space in terms of energy density. Lithium ion stores up to 180 watt-hours of energy per kilogram, while graphene can store 1,000 watt-hours per kilogram. So, what do we have graphene batteries today? The answer is yes, we do, but their high cost has made them hard to produce on an industrial scale. Also, whenever you look at incorporating a fully graphene battery, the cost is high. But to get around that, they have been utilized in hybrid batteries that utilize some of graphene's properties, but to a lesser extent. In a vanadium oxide graphene hybrid, the graphene compensates for the poor conductivity in vanadium oxide, which creates more desirable battery properties. So now that we've discussed graphene in the electrical sense, let's go back to why it is considered the strongest material. So the characteristics between graphene and steel are often pinned against each other, which is because steel is a very strong material. Graphene can be up to 200 times stronger and yet much lighter than steel. In the picture to the right, MIT made a graphene structure that is 10 times stronger than steel when being compared. Graphene also has the ability to be more agile due to its hexagonal shape, and the arrangement has been shown in other compounds and elements to be more appropriate for the transfer of weight and pressure. The future of graphene. Graphene has superior optical, electrical, and mechanical properties. It is expected to become the material of the future, and due to its strength and elasticity as well as its excellent light absorption, it will become the material of the future. And this is without taking into account that its thinness and its energy density capabilities. So why hasn't graphene taken over the battery world? Because it seems like a graphene battery, due to its superconductor properties, should be well worth it. Let's look at some of the costs associated with it and some of the problems in manufacturing graphene. Mass production of graphene is problematic for a few reasons. The first we'll discuss is cost. Graphene is very expensive to mass produce. Right now, it is estimated to cost approximately $200,000 a ton, whereas other battery components that are substituted for it, such as activated carbon, only cost about $9,000 per ton. The price difference is severe, and in a world focused on economic gains, it isn't as viable as we'd like in an industrial setting. But why does it cost so much? So, generating graphene flakes, one, has been hard. If you look at the original process of discovering graphene, they used tape to peel off layers of graphite to get atomically thin flakes. Recently, there have been paths forward that generate graphene in very economical ways and also green ways. Recently, there has been developments at the Rice University utilizing trash in a method called flash joule heating. It heats trash such as food waste, plastic waste, even tires, to a very high heat very quickly, which breaks down the bonds and the carbons and creates graphene flakes. Also, MIT engineers have been working on a method to follow a roll-to-roll approach by combining the graphene fabrication technique of chemical vapor deposition to produce thin, long foils of graphene. So, one of the other reasons it is very expensive to make graphene is production quality. To get a high quality product as well as a consistent product, which is very important when it comes to atomically thin structures, it takes lots of quality assurance as well as expensive methods. And to produce things on a large scale, the best way to produce graphene, such as chemical vapor deposition, is not easily scaled to that level. Another method, which is exfoliation of graphite, is a little more easily scaled but provides varied results that can be different even from the same company from batch to batch. With all of this together, it creates a very expensive material to produce in quality and quantity. One of the other problems that looks to the future is making graphene environmentally friendly. The first thing we talked about for moving forward in the production of graphene was utilizing waste. And that is a method that will ensure the responsible manufacturing of graphene. But another example of going green is a graphene production company called Graphene CR, which has a negative carbon footprint by producing graphene from biochar. And this allows them to effectively reduce their carbon footprint. In conclusion, graphene batteries, even with all of their drawbacks, are highly effective and will be the battery of the future.